A long solenoid of diameter this has this many turns per meter. At the center of the solenoid, a coil of 100 turns and radius. This is placed at its axis coinciding with the solenoid axis. Now the current in the solenoid reduces to 0 ampere from 4 ampere in 0.5 seconds. If the resistance of coil is 10 pi square ohm, we have to find the total charge that will flow through the coil. So what's given to us that this is a solenoid, and this solenoid has a small coil in the center whose axis is coinciding with the axis of the solenoid. Now the magnetic field which will be produced by this solenoid initially will be equal to mu naught Ni, and finally it will decrease to 0 as the current will decrease to 0. Okay. So the flux which will be associated with the coil will be equal to B multiplied by area of the coil multiplied by the number of turns of the coil. So we can say that the flux, initial flux, that will be equal to B, that is mu naught Ni multiplied by, here we are using capital N for the number of turns of this coil, where N is the, small n is the turn density of the solenoid multiplied by area. Area we can write it as pi r square. This will be our initial flux, and final flux will be equal to 0. Now the EMF induced is equal to minus d phi by dt, or I can say phi initial minus phi final divided by delta t, or we can say that EMF will be equal to phi initial divided by delta t. So this is the value of EMF. We have to find the value of the charge. So we can say that charge is equal to current multiplied by time, which will be equal to EMF divided by resistance multiplied by time. Putting the values, what we will have, we have phi initial divided by delta t divided by r multiplied by delta t gets cancelled out, and we are left with q initial divided by r. So which will be equal to mu naught small n I capital N pi r square divided by resistance. Now putting the values, 4 pi into 10 raised to power minus 7, that is my mu naught, multiplied by n is given to us as 2 into 10 raised to power 4 multiplied by current, which is initially at 4 ampere, multiplied by number of turns of this small coil, which is equal to 100, multiplied by pi multiplied by radius square. Radius is 10 raised to power minus 2, so that is 10 raised to power minus 4, and dividing this by the resistance, which is 10 pi square. So this 1 pi gets cancelled out, other pi gets cancelled out. Okay. So now this 10 raised to power minus 4, 10 raised to power 4 gets cancelled out, and now this 10 gets cancelled out, and this 10 and 10 raised to power minus 7, it means the result will be in microcoulombs. Now this is 4 multiplied by 2, 8, 8 multiplied by 4, 32. So that is 32 microcoulomb, which is our option number 3.